This here is an example of a March Madness model that I made according to my grandpa's March Madness system. I've won his bracket 3 years in a row of 50 to 60 people using this method, and I made a more advanced model using what I learned in my business analytics certificate class called spreadsheet modeling. So yeah, so pretty much this will create the optimal March Madness bracket based on the historical probabilities of winning. But if you were to use it for a specific bracket, you would input the specific probabilities on 538 to get the optimal bracket for a specific region. Using my grandpa's point system, 1 point for round 1 win, 2 points for round 2 win, etc. And then upset points. So if a 10 beats a 7, it's 3 upset points. If an 11 beats a 6, it's 5 upset points, etc. And it's pretty much made to create the optimal bracket for that. So I've been doing something like this for previous years, but I made a more formal and advanced version here. So right here we have the probability, historical percentages of each seed winning round 1, the points that they would hypothetically get from a win if they were to win. So it'd be 2 for a 9 seed, 1 for 1 through 8 seeds, and then as you can see it increases as the seed gets higher. And the points projection, so this would be if you were to just pick that team in round 1, the historical amount of points you would get. So as you can see, the 12 seed, picking a 12 seed in an average bracket region is going to give you the most points in round 1. But we also have to take into consideration the possibility of points from future rounds. So for example, so here I just have a winner slot which uses binary, and my solver just solves that out. So it's already solved now, and then a points gained based on that. But as I was talking about, you also have to take into consideration the future rounds. So I have the historical probabilities of each team making it to the Sweet 16, and how many points on average they would get from the win. So how I calculated this, obviously 1 through 4 doesn't have any possibility of facing a seed higher than them or lower than them, however you want to look at it. And then so for like 5, for example, we're going to take the probability of the 4 seed making it to this round and the probability of the 13 seed making it to this round to face the 5 seed as the and we're going to take that and we're going to find the average amount of points that we get from a win. Same with the 6 seed. The probability of them facing off against the 3 seed versus the probability of them facing off against the 14 seed if they were to get to the next round, and then the amount of points that they would get from each of them. So if they were to play the 3 seed, they would get 5 points from a win. If they were to play the 14 seed, they would get 2 points for a win. And I calculated that out individually for every one of these. And the same thing for Elite 8. As you can see, the formulas just get more complicated as you go on for the projected points from win. You can see that continue there. And then based on that, the probability of that times points for win, their points projection for inserting them into the Sweet 16 slot in any given bracket. So the highest in here, I actually believe, is the 1 seed. So 1 seeds make the Sweet 16 84.2% of the time, so that's the reasoning for that. But once again, you have to take into consideration the future rounds, and that just keeps going on until the final 4. And the way I made a solver equation to automatically solve this problem is I have this winner column I talked about before, and then down here I set constraints on my solver that makes it so there can only be one winner from each of these matchups. So as you can see, there's the 1 vs 16, for example, there's a 7 vs 10, for example, and I made one of the constraints in the solver that each of these has to equal 1. The same thing for these future rounds. So like for this one, for example, if you look at it, it can either be the 1, 8, 9, or 16. Only one of them can advance to the Sweet 16. And the same thing with all of these. And I also made this constraint that is saying one of these has to make the Sweet 16, plus 2 of these have to make the 32, advance from the first round. And so I made some constraints there as well. And the final constraint I did to make sure that it couldn't mess this up is that I'll just go into my solver to show you this one. I made it so the values of say column O right here for these, hold on, oops, How do I undo that? I gotta set my objective back. The column for that has to be less than or equal to this column. So it can't just say this team doesn't win the first round, then I'll automatically put them into the Sweet 16. That wouldn't make any sense. So that's how I did that. And then the same thing with these future matchups. I set constraints with this, and set constraints with this, and then I set only one team can obviously advance to the Final Four, and then I set a constraint with this that's 15 total wins and all of this. And so using this information, I have a total points gained column here. So what I did to find that out was you just take the sum of all of these points gained columns, and these points gained columns are only appear as more than 0, like the actual point projection, if the model solver projects them to win, like picks them to win. And so as you can see, I just take a sum of all of these points gained columns here. I add them up over here. Could have just used a sum product, but then we get this right here after summing all of this together. So I go into solver. That's going to be my objective. I want to find the maximum amount. The variable cells I'm changing are going to be these winner columns, and I also have them set to a binary constraint, so they can only be 0 or 1. So they can either get the average point projections for putting them in that slot or nothing, because you can't just, pick a team half the way. That doesn't make any sense. And then I have all the other constraints I already went over. So if we get into solver and we solve this with simplex LP, it's going to say our maximum amount we can have on average. The optimal solution is 23.99. And you can kind of see as I was going, but I'll just review. In the average bracket, and as I said, this could change based on the probabilities of a given region in a given year, but you're going to want to pick the 1 and 2 seed and then all other upset picks. And the 13 and 4 is close. That's sometimes matchup dependent, but on average, picking the 14 seed is the most optimal way to go. Then in the Sweet 16, you want to pick the 1 and the 2, and then the 10 and 11, 11 and the 12. And then the 1 and the 2, and then the 1 to win out. So this is a strategy I've used in past years. You pretty much pick a bunch of upsets in round 1, and then you pick the 1 and 2 seeds to win out or whatnot. Is the typical best strategy. We can play around with this too. We can find the least optimal solution, which is going to get you an average of 7.39. So you can see how it's actually a little bit strategy-based and not as much luck-based using my grandpa's system. And so at the least optimal, you're going to be picking the 4, 5, 6, 7, and 8 to win the first round, and then the 14, 15, and 16. It's interesting to note that the 14 still gets picked in this situation. And then in here, we have the 4 seed, 14, 15, 16 going to the Sweet 16. Then we have the 14, the 16 going to the Elite 8. The only reason it's not 15 and 16 is based on historical data, there was actually one 15 seed that made the Elite 8. So maybe, hypothetically, the 15 and 16 would be more or less optimal. But just based on historical data, the 14 and 16. And then to win it all, the 16. Which obviously is the lowest probability of winning the region. So that's going to net us an average of 7.395906 points. And you can kind of play around with it too. You can take off some constraints, add some constraints, and you can just mess around with it. It's a lot of fun, but this is what I'm going to use for this coming year to hopefully win it for a 4th year straight. So thanks so much for watching. I thought this was a cool little project I worked on here this past week, so I wanted to showcase it and use it on some certain applications I want to submit in the future. So thanks so much for listening to this. Hopefully you found it interesting, and yeah, thank you.